Hello guys, welcome to our session. So today we'll be working through this chemistry multiple choice paper. This one is from the October-November 2024 session. So it's paper 1-1. Be ready guys, as I'm going to do my midwifery job, delivering the best you need to pass your exam. Let us get started. So the first question number one says, which row shows both a property of a gas and the correct explanation to this property? So guys, here I don't want you to claim answers, but I want you to have a deeper understanding in the fundamental principles of chemistry. So I want you to have information or data you would use in your paper two structured papers or in the multiple choice papers. So I want to explain each and every concept behind. I want to explain the principles that are being examined so that you can have a clear understanding, the clear picture of chemistry, right? So I need you guys to have a jotter book so that you can assess yourself and jot wherever you feel like you need attention, right? So the first option, so for multiple choice questions, we use the method of elimination to find the most appropriate answers, right? So here for this table, we shows the property and the explanation to the property. So I'm going to use the method of elimination so that we are going to be left with the most appropriate answers, right? So the first option says gases flow easily. So this is true. Gases flow easily. So here the explanation says the bonds within the molecules are weak. So this sounds true, but it is false. Why? Because for gases to flow easily, the particles are far apart from each other. That is the property which makes them easily to flow, right? So this becomes false. So for gases to flow easily, the particles are far apart from each other, right? Not the weak forces, right? So we go on to option B. The pressure of a sample of a gas increases when the volume decreases. This is true. So pressure and volume are connected by what we call the Boyle's law. So Boyle's law says pressure is inversely proportional to volume. So when pressure increases, volume decreases, right? So uh, the pressure of a gas increases when the volume decreases because the particles are colliding with the walls of a container, right? So this becomes true. Are we together, guys? We go on to option C. So option C says the volume of a gas sample increases when the temperature increases. So this is true. Volume and temperature are connected by what we call the Chau's law. So Chau's law says temperature is directly proportional to volume. So I want someone to mention the other law I've left out in the comment section and state the relationship um, of the constraints that are in use, right? So the volume of a gas increases with temperature due to the increase in motion, right? This is due to the increase in motion, not to the not because of the particles are far apart from each other. So this becomes false. And then the last option, option D, says the spread of perfume particles is due to diffusion. So this is true. And then the explanation, diffusion is the movement of particles from a region of higher. So this becomes false because we have lower here. So it's from higher to lower concentration. So this makes our answer B correct. So B, we have the correct property and the correct explanation. So we now move on to the next question, question number two. So question number two says, when measured under same conditions of temperature and pressure, which gases diffuses at the same rate of nitrogen? So the rate of diffusion is determined by the molar mass. So according to the Graham's law of diffusion, the Graham's law of diffusion says the rate of diffusion depends on the molar mass. So the rate of diffusion, molar, molar mass, is inversely proportional to the rate of diffusion. So this is what we call the Graham's law of diffusion. So increase in molar mass result in the decrease in the rate of diffusion. So we want to find the compound which has the molecule which has the same rate of diffusion as that of nitrogen. So we go on to calculate the molecular mass of nitrogen. So nitrogen exists as a diatomic molecule. So the molecular mass, we add the relative atomic masses 14 plus 14. So 7 is the atomic mass of nitrogen, and then we add the relative atomic mass 14 plus 14, which is equal to 28. So we want to find the other molecule which has the same molecular mass to that of nitrogen. So for ammonia, NH3, we simply add 14 plus 3. So this is not equal to 28. And then for carbon monoxide, it's 12, the relative atomic mass of carbon, plus 16, the relative atomic mass uh, of oxygen. So this gives us 28, right? So 28 is equal to 28 the mass of nitrogen. So we go on to calculate for ethane. So it's C2H6. So it's 12 by 2 plus 6. So this one is not equal to 28, right? So for oxygen molecule is equal to 16 plus 16, which is equal to 32. So this makes our correct answer B. So we now move on to question number 3. So question number 3 says X and Y are both elements, one of which is a non-metal. One more of X and one more of X is added to one more of Y, and they are heated together. X and Y reacts completely to form substance Z. Substance Z cannot be easily separated from to form X and Y. So we are then given three statements. We've got statement number 1, which says Y must be a non-metal. So here the word must rules this option, makes this option incorrect. Why? Because we are given here that X and Y are both metals. We are not told which one is a non-metal, right? We are told that X and Y are both elements and one of them is either a metal. So this one becomes false. Why? Because there's a must here. Are we together, guys? And then we have got statement number 2, which says X and Y for, formed a compound on heating. This is true. X and Y form a compound on heating. So this becomes true. And then we go on to option number 3, which says substance Z is the empirical formula XY. So here we've got the reacting ratio. One more of X react with one more of Y. So this is our reacting ratio. So this is correct because empirical formula, it is the simplest one number ratio of a compound. So this one becomes correct. Why? Because they are reacting in the ratio 1:1. Are we together, guys? So statement 1 becomes incorrect, and then we have statement 2 and 3 as our correct statements. So C becomes our answer. So we now move on to question number 4. So question number 4 says, in an ion is an electronic configuration of 288, right? So this is the electronic configuration of a stable noble gas of period 3, which is neon, right? So the ion is a charge of 2 minus, and the nucleon number, which is equal to 36. So nucleon number, it is the number, the sum total of the protons and neutrons in the nucleus of an atom, right? So nucleon number can also be called atomic number. Are we together, guys? So in ion, it is a charged particle. So we got two types of ions. We've got what we call cat ions. These are positively charged ions, and then we've got anions. These are negatively charged ions. So this one is an anion, right? Are we together, guys? So we go to the question which says how many neutrons are present in the nucleus of this ion. So originally we have got this electronic configuration of this ion, which has got attained the stable noble gas electronic configuration. So we are told that the ion has got this charge 2 minus. So this charge indicates the number of electrons the ion is gained during the chemical reaction, right? So we subtract the number of the gained electrons to find the original number of electrons in the ion. So we subtract 2 from this electronic configuration. So this is the electronic configuration of the ion. And then for the atom, we simply subtract 2, the charge from this electronic configuration of the ion. So it's 2, 8, and then 6 here. Are we together? So the sum total of the electrons of the atom, of the neutral atom, we simply add the number in the electronic configuration. So it's 2 plus 8 plus 6, which is equal to 16. So we want to write this in the nuclide notation. So when the atom is neutral, for a neutral atom, the number of electrons is equal to the number of protons. Are we together? So we have got 16 electrons, therefore we have got 16 protons. Are we together? So the question says the nucleon number is equal to 36, right? So here we've got 36, the mass number. Are we together, guys? So for the number of neutrons is equal to nucleon number minus proton number. So we simply say 36 minus 16. So 36 minus 16 is equal to 20. So this makes D our correct answer. So we now move on to question number 5. So question number 5 says the formulae of two ions are given below. So we have got this ion and then this ion. This ion has got 2 minus and then here 2 minus, and then proton number 34, and then nucleon number 74, 34, 72. So these are what we call isotopes, same number of protons, but different mass number or nucleon number, or a different number of neutrons. So isotopes have got same number of protons, and then uh, same number of protons, same electrons, and then different neutrons. Are we together? So this means they've got different mass numbers. Are we together, guys? So this is what you really need to know when it comes to isotopes. Are we together? So the first statement, which statement is correct? So the first statement says the chemical property of both ions are the same. So the chemical property of atoms are governed by the electronic configuration. So these two ions have got the same number of electrons, so meaning to say they've got the same chemical property. So this becomes true. And then we've got this option B, which says the number of electrons in each ion is different. So according to the principles of isotopes, they've got the same number of electrons, right? So this becomes false. And then the number of neutrons is the same. This is also false. And then the proton number in each ion is different. This is also false. So the correct answer is A. So you really need to know the principles behind each fact being examined, right? So for isotopes, these are what you really need to know, because each and every question lies from this information. So we now go on to question number 6, which says which pair of molecule have the same number of electrons in their covalent bonds. So I want someone in the comment section to give us the general term used to define elements or compound with the same number of electrons, right? Same number of electrons. So here we are given this question. We say same number of electrons in the covalent bonds. So we want to draw the displayed formula so that we can count the number of electrons. So we need to draw the displayed formula for both methanol and ethene. So for methanol, it's C OH here, the functional group. And then for ethene, so this one is in alkene. So this is organic chemistry. So this is what we call the displayed formula. So I want someone to also define what we call the skeletal formula. So we then count the number of electrons in the bonds. So a single bond represents a single pair of shared electrons. So it's 2, 4, 6, 8, 10. So here we've got 10, and then here's 2, 4, 6, 8, 10, 12. So here's 12. So this becomes false. So we now go on to the next pair. So we have got carbon. So carbon to carbon double bond. So it's 2, 4, 6, 8. So here we've got 8 electrons. And then for water, the displayed formula of water in the bent form. So here we've got 2, 4. So we've got 4 electrons. Here we've got 8. So this one becomes false. And then go on to draw for ammonia. Ammonia, the trigonal pyramidal shape of ammonia. Here we've got H. And then here the lone pair of electrons. So the shared electrons in the covalent bonds 2, 4, 6. You've got 6 electrons. And then for nitrogen, triple bond. So this one is what you call the nitrogen triple bond of 960 kilojoules per mole. So this is the bond energy for the nitrogen triple bond. So I've got this question which is frequently examined, which says why is nitrogen inert? So nitrogen, it is one of the inert gases. Why? Because this stronger bond, it is difficult to break. It requires a lot of energy to break. Why? Because of the stronger forces between the nitrogen atoms. So you need to know this information. So we've got 2, 4, 6, 6 shared electrons. Are we together? So this one is equal to this one. So option C becomes correct. So we now go on to the last option for to confirm our answer. So to calculate for the last option is oxygen double bond, and then we've got chlorine to chlorine single bond. So you need to know the bonding between these gases. So if you haven't seen or checked on my playlist, I've posted a video to show the bonding, the dot and cross. So you are being frequently examined to draw the dot and cross diagrams for chlorine, for oxygen, for carbon dioxide, ammonia, methane, ethene. So you need to go and watch that video. So you've got 2 electrons here, and then here 4 electrons. So this is not equal to each other. So this becomes false. Are we together, guys? So we now move on to question number 7. So question number 7 says chrome alum is a salt that contains 2 different cations and 1 anion. Anion is a negatively charged ion, cation positively charged ion. So the ions present in chrome are this. You've got the potassium ion, and then you've got the chromate ion, and then you've got the sulfate ion. So we are being required to find what is the formula of the salt. So a salt, it is a chemical compound which is neutral. So all the salts are said to be neutral. So we need to balance the charges, right? So here we've got +1 for the potassium, and then +3 for chromium, and then -2 for sulfur. So this is not balanced. So it's 4 -2. So the answer is equal to -2. So we need another -2 to balance this +4. So it's minus 4 minus 2 multiplied by 2. So this is plus 4 for the cations, and then minus 2 for the anions. So we need another minus 2 to have minus 4 to balance this plus 4, so that we have a zero charged salt. So our salts have, as I've alluded to, that our salts are neutral compounds. So we need to balance the charges till we reach zero charge. So here we have 2 sulfates, and then 1 chromium, and then 1 potassium. So 2 sulfates, you've got 3, you've got 3, and then you've got 2, and then 1, 1. Are we together, guys? So this one is not balanced because we have got 1 sulfate. So our correct answer becomes B. So we now move on to number 8. So question number 8 says the table gives some information about barium and chlorine. So for barium, you've got the relative atomic mass. So relative atomic mass is defined as the mass of an atom measured relative to 1/12 mass of a carbon-12 atom. So I want someone to define what we call relative formula mass, and differentiate relative formula mass from relative molecular mass in the comment section. So we've got group in the periodic table. So for barium, the relative atomic mass is equal to 37, and barium it is in the group 2. And then chlorine, we've got the relative atomic mass 35.5, and then chlorine is in group 7. So we are given use this information only. Students makes 3 statements. So the first statement says there is more than one isotope of chlorine. This is true. Why? Because we've got this comma. So this comma indicates that there is a possibility of having other isotopes. So from the theoretical information, we've got chlorine 35, we've got chlorine 35 and chlorine 37, right? So this becomes correct. Why? Because of this comma. And then we've got statement number 2, which says there may be more than one isotope of barium. So this one is tricky. So we've got this statement which says maybe. So maybe doesn't give us the absolute certainty, but there is a possibility of having the isotope. So this becomes true. Why? Because we are having a possibility. It may happen or it may not happen, right? So it can be true, right? So statement number 3 says the relative formula mass of barium is equal to barium chloride is equal to 208. So here you simply add the relative atomic masses. So for barium chloride, you need to know the formula. So barium 2 plus, and then chlorine 1 minus. So you exchange the coefficients here. So for chlorine is 1, so here becomes 1, and then the 2 goes there. So it's barium chloride. So you simply add the relative atomic masses. So it's 137 plus 35.5 plus 35.5. So this gives us 208. So this becomes correct. So number 5 is number 8. So the answer is A. Both all the options 1, 2, 3 are correct. So we now move on to question number 9. So question number 9 says which mass of carbon contains the same number of 16 grams of sulfur. So sulfur is on number 16 on the periodic table, having a molecular mass of 32. So this one is half the mass of sulfur. So according to the Avogadro's law, equal number of moles contain equal number of particles, therefore equal number of moles. So 1 mole of sulfur contains the same number of moles to that of carbon. So this is half sulfur. so contains the same number of atoms. So the number of atoms in 1 mole is equal to 6.2 times 10 to the power 23. So this is the Avogadro's constant, right? So the number of 1 mole of sulfur contains this number of particles. Therefore, the 1 mole of carbon also contains the same number of particles. So you've got half mole of sulfur. So half mole of sulfur contains equal number of moles with half mole of carbon. Are we together, guys? And also half mole of any other element. So half mole of 1 mole of carbon contains 12 grams. Are we together? And then a half mole of carbon contains half 12 grams, half of 12 grams, which is equal to 6 grams. So half mole of sulfur is equal, contains the same number as 1 mole, half mole of carbon, which is equal to 6 grams. So this makes B the correct answer. Are we together? And then we've got this option or this question. So question number 10 says a compound X contains carbon, hydrogen, and oxygen only. So it's CHO. So this is the general empirical formula for carbohydrates in carbohydrate biology. So it has an MR of 90, relative molecular mass of 90. So we are told that 100 grams of compound X contains 40 grams of carbon, and then 6.7 grams of hydrogen. So here we've got carbon, here we've got hydrogen, and then here we've got oxygen. So for carbon, we've got 40 grams, and then for hydrogen, we've got 6.7 grams, and then we calculate for oxygen by simply subtracting the mass of carbon and the mass of hydrogen from the total mass. So it's 100 minus 40 minus 6.7. So it's 53.3. So to calculate the empirical formula, we then divide with the relative atomic mass. So we divide by 16 here, and then we divide by 1 here, and then we divide by 12 here. So it's 53.3 divided by 16. So here is 3.33125, and then here 6.7 divided by 1, 6.7, and then 40 divided by 12 is 3.333. Is a recurring decimal, so we divide with the smallest. So we are going to divide with this one, so this one becomes 1, and then store is A. So it's 6.7 divided by alpha A. So this becomes 2.01, and then this one becomes 1. So we round to the nearest whole number. Is 1, 2, 1 here. So the empirical formula is equal to CH2O. So this is the empirical formula. Are we together, guys? So we want to calculate the molecular formula. So molecular formula is defined as the actual number of atoms in the molecule or compound. And then the empirical formula, it is the simplest whole number. So I need to highlight this term because most of the students got it wrong. So this is the simplest whole number. So you mustn't left the term whole number ratio. It is the simplest whole number ratio of atoms in a compound, right? So you need to highlight on this one, whole number ratio, right? So we have the molecular mass of 90. So it's is equal to 90. So empirical formula, molecular formula, it is a multiple of the empirical formula. So we multiply 12, the relative atomic mass of carbon, by x, the unknown number here. So it's 12 by x, and then plus 2, 2x, and then plus 16, 16x being equal to 90. So we add here is 12 plus 2, 14 plus 16, which is equal to 30x, which is equal to 90. So x is equal to 3. So the actual number of moles, the actual number of atoms in the molecule is CH2O by 3. So we've got 2 carbons, and then we've got 6 hydrogen, and then 3 oxygens. Are we together? So this makes C the correct answer.